Thank you. Okay, so this is the first of my talks that really focuses on attention. So let me quote William James, one of the more quoted things, maybe the most quoted statements about attention. So he said, "Everyone knows what attention is. It is the taking possession by the mind in clear and vivid form of one out of what seems several simultaneously possible objects or trains of thought. Focalization, concentration, consciousness are of its essence. It implies withdrawal from some things in order to deal effectively with others." Okay, now two aspects of this are still accepted by almost everybody who works on attention. And that is the selection of one thing and the idea that attention involves both amplification and inhibition. That is, you suppress some things in order to enhance other things. One part that's known to be wrong is that he thought consciousness was of its essence, and we know that's wrong, and I'm going to show you in a minute just one very simple experiment that shows that. And then this stuff at the end about the opposite of attention being confusion and being dazed and scatterbrained. That just confuses attentiveness with attention. But look, he did pretty well with this. So the questions of this talk, and this is why I gave the title I did, are the questions of whether consciousness and attention are related constitutively. That is, whether it's of the essence of consciousness and of attention that they have some relation. Or is it causally or not at all? And I will argue for causally. They're related causally, not constitutively. And I'm going to focus on two questions, mainly on the one, the title that I guess I gave that's on the poster. Can there be conscious perception, and that Axel read, can there be conscious perception without perceptual attention? But first I'm going to just briefly mention the converse. Can there be perceptual attention without conscious perception? Now, I'm sure everybody has heard of blind sight. There's a movie called Blind Sight. I have no idea what it's about. But so, in blind sight, here's the visual system. There, the eyes, you'll notice that they go to this thing in the middle of the head, whose name you don't need, and then the signals go to the back of the head, and this is what's called V1, primary visual cortex, the first cortical area that processes visual signals. Okay, there's this phenomenon. How many have heard of blind sight before? Okay, it's a well-known phenomenon. There's an open question as to who actually discovered it, but the main work on it was done by Larry Weisskranz at Oxford. What he discovered is some people who, for some reason or another, have some destruction of some area, some part of their V1, that puts a hole in their visual field. If you project something to that hole, they say, and you say, well, what do you see? They say, I don't see anything. But then for some kinds of discriminations, if you give them a choice, they can guess very accurately in the 90%. And so here's a cartoon, a somewhat inaccurate cartoon, where the subject, the experimenter says, the subject said, well, I guess the experimenter off in the previous panel has said, what do you see? Or, what is that? And the subject says, but I'm blind, I can't see any stripes. Or maybe he asks, what orientation are the stripes? And then the experimenter says, well, have a guess. And then he says, then I guess horizontal red stripes. Okay, part of the inaccuracy is blind sight does not detect true color, but, I don't know. Yeah, but anyway, it's more or less accurate. Okay, so there is a very simple experiment done by Robert Kentridge. And the experiment is this. He takes a blind sight patient. There's a very, a guy who's on TV all the time, this guy who's known in the literature as GY, but he's on TV so much everybody knows his name. So he says, things are being shown on the screen. He says, I'd be none the wiser if you weren't putting any cues up just to confuse me. In this experiment, he says this. So what is he saying? First, he sees a fixation point. He can see that. His problem is on the right side. He has a left-sided lesion in his V1. So he can see the fixation point, but he can't see this. And he can't see this or this. So what happens is he has a cue, which he cannot see. Then the fixation point again, which he cannot see consciously. Then the fixation point, and then he can either have something on the top on the right, on the bottom of the right, or nothing at all. And it's that he's worried that they're always nothing, okay? He doesn't know that they're not always nothing. And the result is the cue can be up here or on the top or the bottom. If the cue is on the top, he's faster to get to, he's supposed to, I think in this experiment he may be supposed to move his eyes, or I forget whether it's reporting or moving his eyes, but whatever his response is, it's faster depending on where the cue is. Okay, so he's attentionally cued even though he cannot see the cue. Okay, showing that there can be unconscious attention. There can be attention without conscious perception. Okay, so there can be perceptual attention without conscious perception, but what about the converse? So the converse is much more controversial. So you've already seen a number of experiments that suggest that without attention you cannot consciously see. So here's one of the genre which you've seen many times before, but here's a different one. So what's changing? Anybody know? Okay, it's a little harder than the previous ones. Okay. So no attention, no conscious seeing. But maybe, and according to me, that's because conscious seeing tends to regard, not always require, but does not always require a basis in attention. So on my story, attention makes you more likely to be able to see something, but then there are ways of getting people to see something without attention, according to me. Now, I'm going to show you a display, but I'm just, for fun, I'm going to give you a thing to look at. So your idea is, put your eyes on that, okay? What? Put your eye on that square. Fix your eyes on the square. Now, here is a somewhat hard thing to do. Move your attention from one of those discs to another. Try keeping your eyes on that fixation point, but moving your attention from one disc to another. Anybody want to say what happens? Well, you already know. What happens? It gets darker. The one you're attending to gets darker. Okay, and if you move your attention to a different one, you can make a different one darker. So this is a very cool phenomenon discovered by Peter Tse, and I'm mainly showing it to you because some people doubted that it is possible to fixate one place and attend to another. But this is a very good piece of training to get yourself to do that. Now, there's a phenomenon discovered by Arian Mack and Irvin Rock known as inattentional blindness. And the idea of the phenomenon is you fixate there, and then in one of four quadrants you will see a cross. But you're not told where it will be. It could be any one of those four. And either the horizontal bar will be slightly longer than the vertical bar, or conversely, the vertical bar will be slightly longer than the horizontal bar, and your job is to say which, okay? Very difficult because they make them very close. So the subjects are fixating here and they're attending in the periphery, okay? And as it turns out, not only are they attending in the periphery, but they are inhibiting attention to the place where their eyes are pointing, to the extent that if a red diamond appears there, they don't notice it. Or even a word, right? One word that they would notice is their own name, because that will attract attention. We know that that word is being seen unconsciously, because if you then said it, you had the word reason, and then you gave them a stem to complete, R-E-A, and they had to add 3 letters, they're much more likely to complete it with reason than with, say, reader, compared to what they would be without the presentation of that word. So the subject does not report seeing these things, even though the subject would have reported it. So note attention, note conscious seeing. So there are many cases like this, and many people have concluded that conscious perception is constitutively attentional, including lots of philosophers. And those who haven't said that, many often say that attention is necessary for conscious perception. Okay, so any questions so far or comments so far? Okay, here's what I am going, what I'm going to do first, I forgot, this is next. I'm going to show you some experiments that suggest that there can be conscious perception with little or no attention. And it's that little, I've underlined the little because it's simply not conclusive. That's the problem. But it does point in the direction of conscious perception without attention. But the thing is, nobody's been able to show that there's 0 attention. But it's very cool experiments, and I'll show you how they work. Okay, so there's been a whole series of experiments like this done with, by Christoph Koch's lab. Ooh, I got to get them on the screen. When he was at Caltech, there was a period where there's like 6 or 7 of them. I forget which one, I think this might be Fei-Fei Li's experiment. Anyway, here's how it works. You have a fixation point, and then you have this central stimulus, and ignore this stuff for a minute, and at the end, your job here is to say whether those are all T's or whether there's an F in there. Or alternatively, whether they're all F's or whether there's a T. In other words, you're looking for homogeneous letters. And they calibrate this to be extremely hard, okay? It really takes a lot of attention. So they train the subjects on this for, this and the other one I'm about to show you, for 10 hours. Every time you get up to, I think, 80% correct, they make it harder to see by adjusting the timing or adjusting this mask. There's a mask at the end. They adjust the parameters to make it harder. And then when you get up to 80%, they make it harder again. And so roughly 5 hours on this task. People get extremely good at it. If you go and try to do this task, not having been trained, so you have some friend of yours who's been trained, and then you go in and look at it, you say, what? I didn't see a thing. So there you get really good at this. Then at the same time they're doing that, they're also training on another task. And that is, so this was a central task that is in the middle of your visual field. The other task is at the periphery. And it can be in any one of these corners. Sometimes they're in the middle, but it's always in the periphery. It's called the peripheral stimulus. And that is it can be a face, a scene, distinguishing between one face and another. Here's some target images, scene images. You're supposed to distinguish between one and another. It appears briefly, and then there's this masky thing that makes it harder to see. And then you have to say which thing it was you saw. You're presented with a pair of alternatives. Okay, everybody, and you're trained for 5 hours on that. Everybody get the idea? Okay, so you're trained 5 hours on each of those separately. Then comes the amazing thing. You do them at the same time. Okay? So that's what is diagrammed here, is you have these letters, then the letters stay there, then there's this thing, the letters again, then there's a mask for this. The mask is to prevent a visual icon that is a persisting, and then this is another mask for these things. And then at the end, you have to answer the questions about both of them, whether these were all the same or different, and you have to choose between 2 items here. So here is the absolutely amazing result, and I'll explain how to read these graphs. Okay, so this is for this scene versus that scene, this scene versus, I guess, one of these, I'm not sure. This is T versus L, green, red versus red, green. So for the scenes, now the reason I chose scenes and also faces and a few other things like that is that these have long been thought to be processed pre-attentively. It has long been thought that you don't need attention to process certain kinds of scenes or faces, that there's some automatic thing in the visual system that allows you to see it. So that's why they picked those. And what they found was, so here's what this graph says. This is the performance on the T versus L. This is the performance on the picture. And those 100 is the best you did at the end of the training when you did them separately. And so now they want to see, in terms of 100, whether you can do just as well when they have them both at once. And so this person was as good on the central one, almost as good on the peripheral one. This person was better. What it means when they're over 100 is he was better when he did them both at once than when he did them separately. Okay? So similarly, most people are roughly at 100% on the, that is as good as before when they were doing one at a time on the letter thing. And they're almost just a little bit less than perfect on the scenes. And here's another such graph. This is for, can you see the difference between these two faces? This face versus that face. Each of these circles is a single subject. This is psychophysics, which means you don't need very many subjects, and the subjects can be the experimenters. And what you see here is for distinguishing this face versus that face, this is the letter task. So they're just a little bit short of as good on the letter task as they were when they were doing a single task. But one of them is actually over on the face task, better than before. So people, the upshot is, for these things, people can do them, oh, sorry, I forgot. These are harder, and these are things that people are not built to see. Red, green versus green, red. So people are terrible at that. People are pretty poor in upside-down faces. But what they're really good at, and what seems to be pretty automatic and maybe pre-attentive, is distinguishing one right side up face from another. Everybody get the idea of this as kind of a complicated experiment? The bottom line is people can do two things at once almost as well as they could do each one separately when the two things at once are tasks that the visual system is built to do. These very simple tasks. So, I guess the conclusion is little or no attention. But the trouble is the little. Okay, it doesn't really prove, maybe there's diffuse attention to the whole visual field. I tend to doubt that because I think the whole idea of attention is to select among things, to amplify some things and inhibit others if there were attention. I think the evolutionary purpose of attention would be defeated if there was diffuse attention to the whole visual field, but I can't prove that. But what I am going to do is talk about a slightly different question. And that is, can there be conscious perception of an object without attention to that object? Okay, so it's the object is in there, and that makes this a different question. And I'm going to argue that there can be, and the underlying view is that the role of attention is causal, not constitutive. So the crucial notions here are the notion of seeing an object and attending to an object, sometimes called in literature object-based attention. Okay, so what are these things? What is seeing an object? Well, it involves, first of all, treating the object visually as figure rather than ground. And there are many features of figure of ground. One is it appears close. Like the black will ordinarily be treated as figure. It appears closer Smaller, has more of a shape. Also grouping parts together as cohesive, bounded, trackable shapes. So, and there are these Gestalt principles, I won't go into them, that determine that. Okay, so here's a complete list of what I take to be the major features of object seeing. The two I mentioned, figure ground segregation and grouping. I think there has to be a singular element referring to, in your visuals, in your percept, referring to the object. There's what's called binding. That is, binding, if you see a red circle and a green square, your vision binds the redness to the circleness and the greenness to the squareness. So that's what binding is. It is putting features of a single thing together in your representation of that thing. So there has to be the appropriate kind of binding. You have to be able to distinguish between something and nothing, discrimination from other things, and some kind of property attribution to the object. And the most dramatic form is if you can identify it. Okay, so there are a number of different kinds. So that's what it is to see an object. And now I'm going to move. So any questions about seeing an object? As typical with the way I'm thinking about things is there's a combination of a priori and empirical aspects to this. Now, I will mention later something that philosophers have thought is central to object seeing, which I deny. And that is, many philosophers have thought on a priori grounds that what it is to see an object is to be able to single it out with a de re thought, or more informally to ask yourself, what is that with respect to that object? I deny that that is a feature of object seeing, and I will get to why I deny it. But first I'm going to say what I think are the necessary features of object seeing. You know, the lesson here, as in many of the other talks, is that you must combine armchair with science. It's no good just sitting in your armchair if you want to know what object seeing is. Okay, so there are a number of different kinds of attention. I'm going to be talking about, okay, there's spatial attention, object-based attention, feature attention to a property, attention to an object, attention to an area of space. And then in addition, there is what's called bottom-up and top-down attention. I've already mentioned this. I'm going to be talking about mostly about top-down and object-based attention. That is attention to an object. And let me say a little bit about this idea. So this is an idea first noticed by, or put forward by this British psychologist, John Duncan. And here's somebody gave me these slides. I think they must come from someone named Miyamoto, but I don't know Miyamoto. Anyway, here's the idea. You have two things that the visual system treats as objects, this one and this one. And then you have a cue to one of four places. And after this has been given for a while, there will be the thing you're looking for will usually appear at one spot, and let's suppose it's here. Then what you find is that if the object appears, well, these are seconds. You're faster if it appears to the cued place. You're slower if it appears to another place on the same item, on the same object, and still slower if it appears in this other object equidistant from this. So this is the main comparison, the comparison between this and this. These are supposed to be, the screen stretches things a little bit so they're not quite equidistant there. But the idea is that you're faster if it's on the same object. And I'll just go through this quickly. I won't go into all this. Importantly, it works even if the object is occluded. Works just the same if it's occluded. And here's another one. If you see a dot and you're told what color is the corner above the dot, You're faster for here than for here, because here the dot and the corner are of the same object, whereas here the dot and the corner are not of the same object. And it's more than faster. There's these properties too: better search, better perceptual learning, better memory retrieval. So the visual system treats objects differently from the way it treats non-objects, both with respect to seeing and with respect to attention. Okay, any question about that? Okay, so now I'm going to move to crowding. So this is a very philosophically interesting phenomenon. And here is a display due to my colleague Dennis Pelly. Okay, now we have to deal with a certain problem, which is everybody's visual system differs from everybody else's. So why don't we try this one? Try fixating here and seeing if you can see the middle letter. If you can make out what it is. Sorry, not see, but make it out. Or it may be too easy, in which case you may need to fixate there. The idea is, okay, depending on, the idea is this, is that the middle letter is crowded, and people have a hell of a time when they're given this in laboratory circumstances telling visually what that middle letter is. And furthermore, the reason is because you cannot attend to the middle letter, and I will explain in a minute how we know that. But the middle letter is not invisible. And for example, if you're fixating here, you may not know what the middle letter is visually, but you know it's not the same as it is here. Okay? And here's a more naturalistic. So fixate here. Here are two little boys, equidistant from the fixation point. But this one, you can make out much better than the other one because he's crowded by those signs. Everybody get the picture of this? Okay, so here are a couple of statements about what crowding is. So this is my former colleague at MIT, Jerome Y. Letfin, maybe you will have heard of the famous paper, What the Frog's Eye Tells the Frog's Brain. So he's a major figure in cognitive neuroscience. He says, it is not as if these things go out of focus, but rather it's as if somehow they lose the quality of form without losing crispness. And then my current colleague, Dennis Pelly, says, in fact, conditions of crowding that severely impair identification of a letter reported here or orientation of a grading have little or no effect on the detectability of the target, that is, whether it's present or absent. Observers report seeing a jumbled target that incorporates features from the flankers. So the flankers are the things, well, it's clearest in this, is that this is the target and these two things are the flankers. So that's what he's calling the flankers. And he says, he quotes some subjects. Oh, here he quotes himself. He says, oh, no, these are all subjects. What you see on the right, sorry, no, this is him. He's quoting him, sorry, this is him. What you see on the right is a block of 4 letter-like objects, but they aren't clearly A's or B's. They're in between and unstable. The instability is crucial. They do seem to morph. Each letter may seem at times to be an A and sometimes a B, but most of the time it has a confusing hybrid A-B appearance that would be impossible to draw. And then he quotes some subjects saying, it looks like one big mess. I seem to take features of one letter and mix them up with those of another. I know that there are 3 letters, but for some reason I can't identify the middle one, which looks like it's being stretched and distorted by the outer flankers. Okay, so that's the phenomenology of it. Now, what exactly is going on? Well, the explanation of it is pretty well understood. There's some serious disagreements. And my colleague Dennis Pelly says crowding is excessive integration. And here's what that means. If this is the fixation point, and while the person's eyes are focused there, if you look at the visual system further out, what you find is there are overlap, these are not drawn as overlapping, but they're overlapping what are called windows of integration. So here's the idea. If there's one object here, you have no trouble making out what it is. If there are two objects, you confuse the properties of one of them with the properties of the other. They're jumbled in your visual appreciation. And if there are two objects in this, the same thing will happen. If there's two objects in this, the same thing will happen. Of course, as you get closer to the fixation point, the windows of integration get smaller, so it's less likely to happen to you. Now, here's the problem I mentioned before, that people differ from one another. So if you put your eyes on the plus, some people will see row, some people will see or be able to say what they saw, crow or crowd, and others the whole thing. Just out of curiosity, how many can make out the row? How many can make out crow? How about uncrowded? Anybody can see the whole thing? A few people can, wow. By the way, it doesn't matter too much how far away you are because it's the angle of vision that counts. The general formula for making one of these things is that the distance between the items has to be less than half the distance between the middle item, the middle of the middle item, and the point at which the subject is fixating. And you can see that most of these demos have it way more than a ratio of 2 to 1 because they want to make sure it's crowded, but that limits how easy it is to see the things. So here's how we decide whether they've succeeded in crowding something. The procedure, the rough idea of the procedure, you can have a rough idea based on whether you can count the things. That is, fixating here, can you count the things there? How many feel they can do that? Nobody. Okay, good. Then it's crowded for everybody. A better test than counting is stepping. And here's how stepping works. One of them at random lights up where there's some kind of an indicator. And then you're given a series of random instructions of the form move to the right and move to the left. So it'll be told move to the right, move to the left, move to the right, move to the right, move to the right, now move to the left again. And then you're asked to focus on where you are at the end, and then one will light up and you have to say whether it's the one you're on. Okay? Everybody get that? The stepping test? Want to hear it again? No? Okay, so that stepping test, if you can do the stepping test, it's not crowded. Because crowding is, people define it differently, but the fundamental idea of it is it's supposed to be items are crowded if you cannot attend to them, okay? So, now, why can you see the one on the right? The reason you can see the one on the right, like the M in this case, is because you can move your attention all the way to the right so that only the M is in your integration window. So even though the M is more peripheral, you can still see it better than you can see the R. Everybody understand that? Okay, just here are some very quick, I'll go over some of the basic properties. This one, the top one I mentioned before, crowding doesn't impair what is called detection, presence or absence. Oh, this is important. Crowding is cortical. It's not a feature of the eye. So you can feed the target to one eye and the flankers to the other eye, and it works just as well. And here's an interesting thing. Similarity makes crowding worse unless the similarity is perfect. And I'll say more about that. And the other thing is crowding is high level. Here is a demonstration of the last two. Okay, focus on the top plus and see if you can make out the middle item. And now do the same thing here. Okay, the top one is much more difficult, right? How many feel the top one is more difficult? It should be more difficult. And the reason it should be more difficult is because there's much more similarity between the crowded item, the middle picture, and the flankers. right? Okay, now here's something about that shows that there's a way of escaping crowding. You can see the D on the left much more easily than the D on the right because you can use another form of attention, feature-based attention. Here's maybe a better version of it. So the N is more visible when it differs in color. Okay, now we're getting to the main point. It's what I call identity crowding. Okay, so here is an example of identity crowding where I hope that you will be unable to attend to the items. I'm pushing it a little, but I want you to be able, what I want is, so here's the question. So focus on the plus, put your eyes on the plus and see whether you can move your attention from one of those things to the other. How many people feel they can do that? Oh no, so maybe it's too, okay. I'm going to have to make it smaller. Let's try this. Okay, how about now? Can you move your attention from one to the other? How many can? How many can't? Okay, so it's sort of intermediate. Okay, well, I could keep trying, but I'm not going to mess with it. Okay, here's the idea of identity crowding, is that you can identify the middle item without being able to attend to it. This is working for some, but not others. So what I say is that this is seeing an object without being able to attend to the object. Okay? It's object seeing without object attention. And of course there's diffuse spatial attention, but no object-based attention. Now of course the true test would be to see whether attention spreads among those parts of that object, you know, if you pass the stepping test, I think that's a pretty good indicator. So here's the question. In identity crowding, one does know what the identity of the item is, but the real question is that inferential or is it perceptual? Okay, so I have two, what I think of as very strong reasons for thinking it's perceptual. That is, your knowledge of what the middle item is perceptual, not inferential. So what would the inferential story would be? The inferential story would be they all look like the same thing. You have some sense that there is a middle item, and so you infer that it's the same as the ones you can see on the outside. Okay, everybody want to hear that again? Okay, so is it inferential? Okay, so the perceptual explanation, the non-inferential explanation is the reason you can identify it is because if the things are identical, then there's no jumbling, no excessive integration, and that's a perceptual explanation. Okay? So that's one reason why I think it is perceptual. But this is the crucial controversial step in my argument that you can see an object without being able to attend to that object, and I've had many objections. So Michael Tye is one of my objectors, and he insists that it's an inference. He says it's an inference from the apparent uniformity and the fact that the ones you can see are lines. Okay, now it turns out there is a really good piece of evidence that it is not an inference. And I'm going to, let's see, I just want to keep track of the time. I'm going to show you that. And incidentally, so what I'm going to do, here's what the rest of the talk is going to be. I'm going to show you that evidence. And then I'm going to show you how these considerations I'm raising solve the traditional philosophical puzzle of the speckled hen. Okay? So I'll say what that puzzle is. But first I'm going to tell you this argument that it's non-inferential. So this is directed against Tye. So there's this extremely interesting article by my colleagues at NYU, Jeremy's now left, and Eero Siemencelli. And here's what they were able to do. They used a computer algorithm that Simoncelli had developed. The purpose of the algorithm is that it duplicates what people see in peripheral vision, okay? And the algorithm could, it's not perfect, and it can use some more tweaking, and Ruth Rosenholz at MIT has tweaked it further so that it duplicates the properties of peripheral vision pretty well. And I'll show you something of hers, but here's how you can see what's going on. So here is a picture that has been partially subjected to that procedure. Do you see these lines here? Look at the intersection of those lines, which is right here, okay? This thing, if you're fixating here, the idea is, so fixate where the lines cross. If you're fixating here, the rest of the picture should look normal, like what the original picture looked like, okay? And if you then stop fixating there, you can look and you see this stuff looks very weird and distorted. But that's what peripheral vision does. It does that stuff. Here's the same picture with a different fixation point, namely here, and now you can see this part all weird and distorted. The article is called Metamers of the Ventral Stream. The ventral stream is the conscious vision. Have people heard the word metamer? Metamer means things that are different but look alike. It's often applied to color. Color metamers are things that are very different in the reflection processes but look nonetheless the same in color. So, okay, that's what metamers are. Here's another one. Okay, so let's so this is one of those Where's Waldo things. I don't know if you're familiar with them. So fixate here, and then this should look normal, or fixate here, and then this should look normal. But you can see what your visual system is actually doing to it. So it's really making weird things. Okay, so roughly the way this works, this is an algorithm due to Portilla and Simoncelli. And what it does is it takes a picture and a random seed, and then it texturizes the picture over these pooling areas. If anybody's interested in this, there's a very good primer on this, written in English rather than mathematis, by Ruth Rosenholz. And if anybody's, I think I refer to it in one of my papers. So here's the thing. The ones I've shown you, the texturization process depends on a fixation point. But it's kind of cool to look at the ones that don't depend on a fixation point. And here's an example. So here's what they did. They took this picture as the start. They combined it with the random seed, so it'll be somewhat different each time. And then they texturized it, and here's what the texturization looks like. Okay, so that's what you would, if you looked at this entirely in peripheral vision, like fixating out here somewhere, so it's entirely in peripheral vision, what you would see was stuff that looks like that. Everybody get what's going on here? They put the original in the middle, and then what you see around the edges is the texturized version, which shows you what it would look like if that picture was totally in peripheral vision and inside one of those windows of integration. Any question about what this is? You sure? Because stuff won't mean anything to you if you're not absolutely certain what it is. No, the yellow line is just like for us. The yellow line is like, this is the original picture. And it's a little confusing the way they did it. They could have put this down there, and then it would have, but anyway, any question about it? I'll show you a few examples. So here's another example. You see what texturization does, and here's another example. Okay, so I've shown you certain kinds of examples, but not others. Now I'm going to show you something surprising, okay? Here's what you get if you put a regular pattern. So this stuff is the texturization of that. Whoa, you may say, what's going on here? Why is it so much the same? So here is the explanation that Simoncelli gives me when I ask him that question. Here's what he says. He says, look, what happens in peripheral vision is basically it's a compression. It's like what happens when you take music and compress it into a form like for an MP4 player. It's a compression of the signal. And here's the thing. Sometimes a compressed signal, if the signal is regular enough, the compressed signal isn't very different from the original. Okay? So the compressed version of this is just the same thing because it's so regular. It doesn't need to be different. So something regular in peripheral vision doesn't look, if it's regular in the right way, it doesn't look that different from the original thing. Here's another example. Here's an example of something that isn't quite as regular, but you can see it's a lot better than the Feynman picture that I showed first. So here's some comparisons. Okay, so I asked Ruth Rosenholz at MIT she has this up on her computer and is using it all the time. I asked her to take 3 letters and to texturize it and see what happens. And here's what she got. Those are 3 letters seen entirely in peripheral vision. And what you see is when you get a case of crowding, what happens is the visual system produces something that's pretty close to the original. She didn't do it with lines, but lines would be better because these aren't perfectly regular because they're, the top and the bottom are different of a T. So here's the idea, that these very regular patterns are simply not as degraded as in peripheral vision. Peripheral vision really does pretty well, even when they're all in one window of integration. And, okay, so this is all by way of responding to Ty. So Ty says, oh, no, look, it's not perception. You're not perceiving the middle item as a single line. No, you're inferring, and what this is meant to show is that the process that underlies it is perceptual. This algorithm is meant to duplicate the perceptual effect of peripheral vision. So this is all by way of replying to Ty, showing that it is genuinely perceptual. Okay, so here is the interim conclusion. So the identity crowd item, the item in the middle, you can identify it and not by inference, discriminate it from other objects, detect it, differentiate it from the background, bind properties to a singular element. Now, I haven't justified that, and the argument for that would take way too long, but it's in one of the papers that you can find on my website. I just want to caution that there is spatial attention to vicinity. Okay, now I'm going to move to the idea of grain. Okay, and this is where we lead into the speckled hen. Okay, so the grain of attention is the smallest angular separation between objects that enables attending to an object as distinct from surrounding objects, and the measure is the stepping, as we saw. What is the grain of vision? The grain of vision is the smallest angular separation between objects that enables seeing an object as distinct from surrounding objects, like to distinguish a set of things from a uniform field, 1 dot versus 2 dots, the gap between 2 disks that are rotating, and you can tell which direction they're rotating. So the grain of vision is basically the same as what is sometimes called acuity. Can you tell one thing from 2 things? If so, then the grain of vision is fine enough for you to be able to discriminate 1 from 2. Now, tests on the grain of vision and the grain of attention show that the grain of vision is much finer than the grain of attention. An arc minute is 1/60th of a degree. Okay, everything's measured in degrees. So the grain of attention is 3 to 10 arc minutes at the fovea. Whereas the grain of vision is 1 arc minute. So the interesting category are things that are between the grain of attention and vision. big enough to be seen, but too small or too close together to be attended. Okay, and that's what I think you've been seeing in these crowding, the identity crowding cases anyway. Here's an important factor, which is the grain of attention increases with eccentricity more than the grain of vision. At the fovea, there's a difference. Attention is 3 times coarser, but 15 degrees off the fixation point, it's 20 times coarser, which is why these displays using peripheral perception are so much more impressive. Okay, now on to the speckled hen. Okay, the most significant treatment of the speckled hen is one by Roderick Chisholm in Mind, 1942, and he bases it on something that A.J. Ayer says in 1940, and Ayer said that he got it from Gilbert Ryle. So this is a venerable problem, and here is Chisholm's statement of it. Our problem pertains to the question, how many speckles... so Chisholm at this stage believed in sense data. How many speckles does the datum comprise? Okay, so just to put this in modern terminology, well, okay, I'll read what he says and then put it in modern terminology. C.I. Lewis has written that there can never be positive bafflement in the presence of the immediate, that is immediately perceived, because there is here no question. Well, that seems like the wrong. Should be here is there. I don't know what that's supposed to be. Because there is here no question which fails to find an answer. So that's from C.I. Lewis. But what of the question about the number of speckles? If we judge that there are 48, it would seem at first consideration, at least we might very well be mistaken. But our judgment is not about a material thing, and apparently it's not about a prediction about further sense data. This seems especially evident when the datum is judged to comprise 1, 2, or 3 speckles. And our difficulty is not that there must be characteristics of the many speckled datum which pass unnoticed. It is more seriously the fact that we are unable to make a reliable judgment about what we do notice. So the idea is, you're looking at a speckled thing, and let's just stipulate that there are no cases of speckles that merge into other speckles where there's an indeterminacy of whether it's 1 or 2. Just make them the clearly differentiated speckles. Okay, so if the speckles are close enough together, what you'll find is not only do you not know how many speckles there are on the hen, but you don't know how many speckle representations there are on your percept or image of the hen. And since the percept or image is the immediate or the given, it seems paradoxical that you could fail to know how many there are, because as C.I. Lewis says, there cannot be positive bafflement in the presence of the immediate. Okay, so that's the problem of the speckled hen. Note, by the way, that we're talking about perceptible properties. Okay, so now I'm going to solve the problem of the speckled hen, giving the materials you've just seen. So I need the idea of tongs. Is this a word in Spanish? I don't know. That's a pair of tongs. The tongs is something that grabs something. Everybody okay with tongs? So, what? What? Pincer, yeah. Okay, so the pincers of vision and the pincers of attention. Okay, so we need to have the concept of the pincers of vision and the pincers of attention. So maybe let me just move. I've got this maybe in the wrong order here. Okay, so here's the idea. Here, both the pincers of the blue is the pincers of vision, the green is the pincers of attention. Now the idea of pincers is you can open them up, but they may have a minimal, grip. So both vision and attention can grab one of these stars because you can open up the pincers and grab it because it's fine-grained enough to do that. Here, these things, so what you're seeing here is the minimal amount you can squish it down. Here, neither attention nor vision can grab a single star, because if you try to grab it with this thing, it'll always slip out, right? With both vision and attention. Now here's the crucial case, that vision can grab a single star, but attention cannot, because attention is too coarse-grained. Okay? So that's what we've been seeing in those lines that are in, assuming they were genuinely crowded for you and you couldn't step between them. That's what we've been seeing. We've been seeing this case. And that's what's going on in the speckled hen, which is that you can see the things, but you can't attend to them. So that's why you can't count them, because you can't attend to them. Okay, so that is the solution to the problem of the speckled hen, is that the grain of vision and the grain of attention are different, and attention is coarser, much coarser. Okay? So, well, okay, that's my solution to the speckled hen. So C.I. Lewis says there can never be positive bafflement in the presence of the immediate, because there is here no question which fails to find an answer. The speckled hen says, not so, Professor Lewis, because of the coarse resolution of attention. Okay, I'll skip that. Okay, let's see. I guess I'm almost out of time. Am I out of time? What? No. What? Okay, so I'm going to go into some objections. One objection is, look, there are many different senses of C, depending on the grade of identification, differentiation, detection, binding, etc. So the issue of whether we see crowded letters is just verbal. So my response, it should not be a big surprise, in discussing seeing, we should be cutting nature at its joints. So one proposal for the joint for seeing, and this is Burge's proposal, is seeing is an objective sensory in the visual modality representation, that is representation by the individual rather than a subsystem. So if he's right, that is a joint. He doesn't talk about object seeing, but I already gave you the conditions of object seeing. So here are some objections from Michael Tye, who I've had a few rounds with Michael Tye on this. So he says, consider this. So he looks at a display, which I've made very small. It's not meant to be. This is a display from a paper by Patrick Cavanaugh. And the idea is supposed to be, you're supposed to be presented so that these are crowded, but these aren't. I mean, I'm sure for you, both will be crowded, right? Consider the sixth bar away from the plus sign on the right. As you fix that in the plus sign, you cannot mentally point to it. But so, okay, so mental pointing is just attention, so why should that matter? You certainly see each bar on the left. What about each bar on the right? If you think you see each such bar, tell me how many bars there are on the right without moving your fixation point. You won't be able to do it as you can with the bars on the left. Why not? Well, because my answer to why not is because you can't attend to them. Surely, I love his use of surely here, because it is not the case that each bar on the right is clearly marked out or differentiated in the phenomenology of your experience. But then surely, even though you are conscious of the bars on the right, it is not true that you are conscious of each individual bar. So what is this marked out or differentiated? If differentiating is a matter of figure ground segregation, then both sides are plainly differentiated. And here's my version of this. I think if you use one where the crowding distance is too large, it can be very difficult. Okay, so here's the more serious point, though, and this is something where he has a similar view to many philosophers. So this is, well, I think, of more philosophical significance. This is a proposed condition of object seeing. I am conscious of a thing just in case my experience has a phenomenal character directly on the basis of which I can at least ask myself, what's that, with respect to the relevant object. So the directly here is meant to rule out inference, and the can here, the modality, the idea of it is without moving my eyes and within the task demand limits. So my point of view on this is that this is a cognitive requirement on conscious perception, that you don't see something unless you are capable of de re thought about it. or demonstrative thought about it. So I'm very, very, very suspicious of this. Here is Susanna Siegel, earlier than Ty, I should say. She says, if one sees an object O, one can form a de re mental state about O, or demonstratively refer to O just by exercising whatever general apparatus is needed for de re mental states or demonstrative reference. No specific background beliefs about O are needed. The experience of seeing O suffices for forming a de re mental state or for making demonstrative reference, so long as the subject has the cognitive apparatus needed for these things. Okay, to me, this qualification ruins the whole idea. Okay, once you admit it's not really true, then that seems to me to be, to really make it clear that you cannot have a cognitive requirement. That's an ad hoc limitation because she's seen a counterexample. And furthermore, we can see that this, especially from the stuff I presented earlier about how cognition could go wrong even when perception isn't, like in those neuropsychology cases. The subject could have a cognitive apparatus but not be able to use it for this particular purpose. So if she were to try to make this out, she would have to put in a further ad hoc condition. Okay, remember the Bergian idea that I started with, where the border between perception and cognition was this. So, right, he says all perception is demonstrative, which I think is the grain of truth in this idea. But whether the subject is capable of forming a perceptual demonstrative judgment depends on cognitive capabilities and, importantly, also on their access to perception. It's not good enough to say, as Susanna Siegel says, if the subject has the right cognitive capacities. There's more involved, and there are many ways things can go wrong. Here is an example that I believe I mentioned before. The jumping spider identifies and stalks its prey, but we do not know whether it has any cognition at all. It's clearly perceiving its prey and tracking it, but forming a demonstrative judgment or a de re judgment about the prey, I mean, who knows whether a jumping spider can do that? Who knows whether a small child can do that? So now, I don't want to make an empirical claim about jumping spiders not being able to do it. Look, a problem is the jumping spider's vision may not be conscious. But here's the real point, which is that if, as you look at the phylogenetic scale, the cut in nature between creatures that have conscious vision and creatures that have only unconscious vision cannot be assumed to be the same as the cut between creatures that are and are not capable of demonstrative thought or de re thought. So we could easily have a creature that is capable of conscious vision but is not capable of conscious or de re thought. My own view is that a child probably is such a creature, but I can't prove that. Okay, so here is a summary, which I gave before, I guess. The subject can visually identify the carotid item and not by inference, discriminate it from other objects, detect it, differentiate it from the background, bind properties to it. So I just don't see a reason for denying that the subject sees it other than the absence of attention. Okay, so now let me just mention this, it seems to not be properly displaying. Okay, so that's supposed to say conscious perception is not constitutively related to, what can I get this to display? Let me try again. There it is. Cognition, representation, or attention. And so the first four talks were about cognition, the fifth about representation, and the sixth is, this one is about attention. And, the idea is that consciousness is a sui generis thing, not philosophically reducible to anything else. It may be empirically reducible, but not philosophically reducible. And that's the end. Okay.
I have one clarificatory question. I think it's not going to be an objection because it might only go in your favor. But anyway, when I presented the results of these results where scientists were trying to emulate how perception in the visual system works, and you made it with TTs.
Yeah. Okay.
Maybe you should start over.
Yeah. Okay. I start again. So I'm having in mind these the results that you were presenting from this scientific group of scientists trying to emulate how we perceive things in peripheral locations, and then you ask one of them to do it with crowded cases. One problem that I have with this is that in the example of Feynman that you were presenting, faces are crowded to something that is fused into something that's clearly not a face. Now, I don't know whether there is any evidence and I didn't have the time to digest all the things in order to see in which direction this might tilt the scales. But for instance, right now, it seems to me that I am perceiving faces here, so people in the periphery, and I wonder whether this could be seen by seeing whether it's just an inference or it's something perceptual, by seeing, if you are right, from what we learned from your talks in the first day, that activation of the fusiform phase area is visual, is perceptual. So in those cases, if it's a perceptual phenomenon, what's going on in here is not inferential if there is activation of the fusiform phase area. So my question, I guess, is there any evidence in this direction? So there might be this, something that might be called inferential somehow, but causing something that is perceptual activation. I don't know whether it's clear. Can you help me?
Yeah. Okay, so there's something I forgot to say that I should have said, which is that I am definitely not arguing that in crowding you see the crowded item generally. I am only, and the reason for that is generally, you need a perceptual demonstration to see something. And, those things get jumbled together, and I don't know that you can have a perceptual demonstration of a crowded thing if they're all different from one another. It's only the identity crowding cases that I say are seen. The object seeing is only supposed to apply to the identity cases. As to whether the fusiform face area would react to a jumbled face like here, I'll show you. See if I can find it. Yeah, like that Feynman. I doubt it, but I don't know that anybody's ever tried. I mean, actually, Ruth Rosenholz is in the same department as Nancy Canwisher. They should get together and try it.
So, and let me just, if you don't mind, speculate a little bit. So let's assume that now in this foveal area is axial phase, and let's imagine that the fusiform area is firing. Seems so because I expect there are some expectations for me there to be people, and or I don't know. So what would be, and that's absolutely a speculation. You can say I don't like this kind of things. That would be perfectly fine. Well, how would you interpret this data?
Okay, so I'd be surprised by it, but one way I would not interpret it is that people are seeing the face, because look at this. You can't tell where one face stops and the other face starts. I think what that would show is the fusiform face area is responsive not to objects, but to kind of, something that you might categorize as a face texture, face-ish texture. But that wouldn't be the same as seeing an object.
I have a question also. In the last part, you were showing that there could be conscious perception without attention. And then you jumped to the conclusions, and it seems to me that you try to put together attention and cognition. If there is no attention, there's not cognition. But in the first part of the talk, you were arguing that there could be perceptual attention without consciousness. So my question is why you are putting together in this last part attention and cognition?
Yeah.
Because there are two different kinds of attention, isn't it? One just perceptual and the other cognitive.
Okay, so let me...
attention is an independent phenomena, both from perception and from cognition.
Okay, so here's the dialectic as I see it. In the beginning, I was focusing on the question of the relation between conscious perception and attention, whether conscious perception is necessary or sufficient for attention is necessary or sufficient for conscious perception. So I first presented the blind sight case to show that you could have attention without conscious perception, and then I looked at those cases where you have conscious perception with little or no attention. Okay, so the latter did not have a conclusive ending. So because conscious perception with little or no, that's not the same thing as no. So and this has been going on now for a while. Nobody knows how to show zero attention. So I was proposing a more kind of fine-grained issue. Instead of focusing on conscious perception and attention, focus on conscious perception of an object seeing without object attention. And then I was, so object seeing without object attention, then I introduced crowding. Now, so I claim that in identity crowding, in those cases with the lines, we have object seeing, the middle crowded item, object seeing without object attention. However, my opponents, like Michael Tai, say, I'm only conscious of a thing if I can have de re thought about it. Mm-hmm. And then the problem comes, sorry, I forgot to say this. The problem comes with this. I don't claim that you can have de re thought. I think you can see those items, but I don't claim you can have de re thought about them. But I think the reason you can't have de re thought about them is because you don't know whether you are locating one versus another. That is, if you're having de re thought about it, you should know which one you're talking about, but you don't. Now, I think it's a lot easier in the case with three, but I think generally in identity crowding, there's no possibility of de re thought. Okay, so I am motivated. Oops, that's not it. Where is the de re thought one? I am motivated to reject this principle. So I'm mounting a rear guard action against the principle that there's this cognitive requirement on perception. And so this is by way of reply to an objection. So I'm saying, so the dialectic is I take myself to have shown that the identity crowd is seen. But then my opponents say, well, how can you say it's seen if you can't, on the basis of seeing it, perceptually demonstrate it? So I say, I don't believe this perceptual demonstration condition. So, for example, I think babies probably can see things without being able to perceptually demonstrate them. Perceptual demonstration, form a perceptual, form a de re thought about it. So forming a de re thought about it is a sophisticated thing. I don't think it's a condition on perception. So that's why I was going into that.
But my question were more in the sense that do you think that there could be a conscious perception without perceptual attention? Because there is something like perceptual attention that is not cognitive.
Yes.
related to the first part. So there could be the possibility to be conscious
Yeah.
without attention at the level only of perception,
Yes,
without cognition.
that's this. I claim that the middle item is something you can see, you can consciously see that object, and for many of us, you cannot
You're
attend
not
to it. Not
attending.
all of us, but for many of us, you cannot
Yeah,
attend
but-
to it.
no, no.
I'm trying to relate to this yesterday with what you said yesterday, and I don't know how well it fits, because yes, one of the conclusions of...
No, right. Okay. One of the conclusions for yesterday's talk was that both the attended and unattended are veridical, right? So this was here, wouldn't that mean then that our jumbled perceptions are also veridical? Because then if this is so, then what you replied to Sebastian wouldn't work, because then he will be able to say, no, the jumbled faces are also veridical, and so if the results that he proposed work, then we should say that also we're seeing faces in the jumbled case, right?
Yes. So I actually made an explicit exception, which is meant to deal with a case like this, maybe not adequately though. I said it's veridical with regard to the things you can actually see.
Okay.
So remember the experiments I showed.
Mm-hmm.
I mean, one good example is in the case of those grids in peripheral vision. The experimenters were very careful when they were looking at 20 degrees out to use a very widely spaced grid. Because if it was more narrowly spaced, the subject wouldn't be able to see the damn thing in the sense of being able to tell it from a uniform gray field. Their acuity wouldn't be enough to separate the lines from each other.
But then, since we do see this
Yeah.
line in the middle, even our jumbled image of that line in the middle would
Well,
be
I
veridical.
claim this one isn't jumbled.
Oh.
So I claim that one isn't jumbled. The ones that are jumbled are
the ones that you cannot
are the
see.
ones, yeah, are the ones like, let me find them.
But you remember the image you showed us of the teeth, and the teeth all
Yeah.
kind of jumbled.
Yeah,
Even if it was a little jumbled, you could
Yeah.
still, I still think we can say that there is a level of jumbledness that
Yeah.
even though it allows us to identify the line or the letter,
yeah,
it's still there. And then you would have to also say that those jumbled, even if a little bit jumbled, but enough to identify things, are veridical. So you would have to say that these 11 representations of the teeth, the 11 are veridical.
yeah. Okay, so remember when I quoted what the subjects say about these crowded stimuli? They say things that clearly indicate a dynamic perception. The things are, changing as you see them.
Okay. Yeah.
They are, stretching. It's not exactly they seem in motion, but it's different from moment to moment. Why is that? Well, that actually is duplicated in this with this algorithm by the fact of a random seed. So that's very nicely expresses the fact. So what she did here was she ran this algorithm again and again with a random seed to get these different pictures. Mm-hmm. So maybe if I was stating my what I'm arguing for a bit slightly more carefully, I would say something more like, you can usually see the crowded item, or most of the time you can see the crowded item, or something like that. So I agree that, so certainly this one, there I would not claim to see the crowded item. That really is a jumble.
Thank you.
So
that makes sense.
So the nature of crowding appears to have that dynamic, changing aspect to it. So you're right. Thanks for asking that. I should have said that.
Yeah. No, thank you, actually.
Oh, yeah. I got my own. Yeah.
Okay, finally. Most of the experiments that you presented imply the use of top-down directed attention.
What?
Top-down directed attention. And maybe, and you infer from there some of your models of the openings of the tongue for attention, for vision. I wonder if the results would be the same if somebody has studied bottom-up stimulus-driven attention. It's a classic division in attention research, and I wonder if it applies the same. Moreover, in top-down directed attention, you can have, and I guess some of the experiments show that, you can have like a pinpoint, can you say, very focused attention or wide open, which requires, in some of these cases, it requires like an open umbrella type of attention. And I wonder if these systems that probably have neural bases would change your views on the model that you're proposing. What do you think about that?
Yeah, that's an interesting issue. It's very hard to do. I can't offhand imagine how you could possibly do an experiment. You know, the stepping procedure requires the subject to voluntarily move attention from one thing to another. If you try to get the subject to move attention by attracting attention to one thing than the other, you'd immediately have to put some feature on it which would distinguish it, and then you'd get the problem I raised, or the issue that I raised earlier on. Let's see, I'll get that. This. As soon as you change a feature, you get rid of the crowding, because feature-based attention can just get rid of the crowding. So I don't know how you do the experiment, but let me say more generally, look, I'm always reluctant to say you can't do it, because somebody, clever person, figures out how to do it. Let me say that I think one of the things that Marissa Carrasco has shown is that bottom-up and top-down attention are very similar in their mechanisms. They're different in a variety of ways. Of course, the timing of them is different. You know, top-down attention takes 300 milliseconds. Bottom-up, it takes 100 milliseconds. But the experiment she has done, almost every phenomenon works pretty similarly for both bottom-up and top-down attention. So what she has shown is that top-down attention is a bit more flexible. So it's a bit more optimized than bottom-up attention. So my guess is if somebody could figure out how to do it, you could get exactly the same phenomenon with bottom-up attention.
Thank you.
So it seems to me that the Michael Tai and Susanna Siegel notion of seeing, it's more friendly to pre-theoretical uses of the word. And this is not an argument against you at all. So it seems to me that you have these examples where, an object is in our field of vision and plays a role in our judgments and our dispositions. And then your suggestion, which seems very plausible, is to say, well, we have to extend our notion of seeing and say that you really see that object, even if you don't have a direct thought about it. But there seems to be another option, which is just to say what I said. The object is in your field of vision and plays a role in your judgments, this and that. So I would guess that you believe there is a theoretical benefit of expanding this notion of seeing, rather than preserving the pre-theoretical one and explaining these cases in this other way. And I wonder what those reasons are.
Okay, I reject your way of putting what I say. So you say, I am extending the notion of seeing because I think there's a theoretical benefit. I deny that's what I'm doing. Here's what I claim. I claim that our notion of seeing is a natural kind notion. Mm-hmm. That what we want to do with our notion of seeing is cut nature at its joints. Yeah. I think unconscious seeing is seeing in the normal notion of the term. That doesn't mean it's familiar to everybody, but when people discovered that there could be unconscious perception, first subliminal perception and then many other things, they were not making a stipulation. They were finding out more about seeing what we always meant by seeing. You know, I think this is an extremely important point in philosophy. You know, I'm old enough to remember Oxford philosophy in the 1960s, where they used the phrases of the form, it sounds odd. So they said, Oxford philosophers actually said things in my hearing like, it sounds odd to say that somebody is drinking a glass of H2O. They thought, I mean, I'm not sure if they would have put it this way, but you were extending our notion. You were making a stipulation to say we could drink a glass of H2O. But actually, what we always meant by water was whatever water is. And it's not an extension. It's unfamiliar. It may be odd, but it's not an extension. And I think the same thing for seeing. I think that the fundamental pull in what we're talking about when we talk about seeing is a natural kind pull, a pull towards the joints. And so I think that the jumping spider sees that that's an ordinary claim and not a stipulative claim and not an extension claim. And I think it's also true that the baby sees, and we have tests of their acuity. They see pretty well, but I really doubt whether they have the capacity for de re thought. So I don't think that's at all an extension. I don't think I'm claiming a theoretical benefit for an extension. I think that the basis of our thinking about seeing is that we are trying to pinpoint a real phenomenon.
Can I follow up quickly?
Yeah.
So I can phrase the question in a slightly different way. I could say, well, you know, some people think that this pre-theoretical notion of seeing carves nature at the joints, and then you believe that there is this other notion of seeing that is wider because it you know, more cases count as seeing. You believe that one carves nature at the joints. And I would think that if you believe that, you must think that there's a theoretical benefit of going that way rather than the other. And I cannot see with clarity what the benefit would be.
I just don't see the case for saying that to say that a 3-month-old baby does not see is cutting nature at its joints. I think that anybody who says that on the grounds, so suppose we discover, as you know, probably we one day will, that a 3-month-old baby is not capable of de re thought. Now, I actually have good reason for thinking a 3-month-old is not capable of de re thought, and I could tell you, in fact, I will tell you. Some wonderful experiments by the neuroscientist Peter Huttenlocher. I think I may have mentioned this, but I'm going to mention it again. He did these, you know, basically horrible experiments where he looked at the brain of people of various ages who were dead, and he could actually, look very closely at the dead brain. And he started with the eventual result was a graph of the ratio of synapses in perceptual areas as compared with frontal synapses. Now it turns out that the newborn baby, and until I think maybe 6 months, has very few frontal synapses, but its perceptual system is working fine. Babies can imitate, the newborn baby in the delivery room can imitate a person sticking out his tongue, opening his mouth. And if you want to find videos of this, you can find them online. This is some experiments done by people at the University of Washington in Seattle. Just look up YouTube video of newborn sticking out tongue. You'll see the videos. Okay, the newborn baby can see. I have absolutely no doubt that it is incapable of de re thought. It doesn't have a frontal cortex. Most of what it's doing is, the brain basis of it is in the back of the head and the subcortical machinery. I have absolutely no doubt that the newborn baby is seeing, and maybe some more work will be required to completely nail it, that it is not capable of de re thought. So I think to say that you're cutting nature at its joints when you say the newborn baby cannot see, or even the 3-month-old cannot see, it's just wrong. That's not the joint.
Thank you.
May I put the question first? So I would like to come back to the blindside case. So your diagnosis is that we have the perceptual attention without consciousness. So my question is the following, taking into account the stuff of previous sessions. Why you don't describe that as phenomenal consciousness without access consciousness?
Yeah. Okay. It's interesting that you, I have had a lot of trouble with this issue. In fact, there is a paper by Ian Phillips, an Oxford philosopher, arguing that very thing. And Ian and I are, actually, not quite what he says, but one of the things he says is why I don't regard it as phenomenally conscious. And he goes into a lot of stuff about blind sight, which would argue that maybe it is phenomenal. So blind sight is a very complicated phenomenon. So, and in fact, Ian and I are about to have a debate on this topic. Somebody is collecting debates on major issues, and we're about to have a debate on unconscious perception. What can I say that... So look, I guess the first thing is it's a debatable issue. There's been since the beginning of blind sight, there have been people who were skeptics about whether blind sight patients really were blind in the sense of no conscious vision. I believe in unconscious perception. I think the clearest cases are cases where, like that guy GY, he says, I would be none the wiser if there were never any signal here. The fact, that seems to me to be pretty good evidence, not conclusive, pretty good evidence. If somebody is, seeing things, it's good evidence that someone is seeing things unconsciously if they swear up and down that they have no idea whether you are presenting something or not. And if I got out the red and green glasses, I could provide a case where, I already showed you the binocular rivalry, but there's a much better version of that binocular rivalry thing, where you will swear that you are not consciously perceiving, say, the face, but we can show you're perceiving it. So the big problem in studying consciousness is that no one has a criterion for consciousness when it's conscious perception versus unconscious perception. And so it's always a debatable issue, whether a given... Now, it turns out, so there can be disputes about blind sight, and there are disputes about blind sight. There is another version of that experiment that uses normal people. It's also, when you've got a brain damaged person, it's another reason to be skeptical, because they're brain damaged. Maybe something to do with the brain damage is affecting their reporting or something. And in fact, that is one of the alleged problems with, in studying perception, there is this piece of machinery called signal detection theory. The idea of signal detection theory is that whenever you make a report, suppose somebody shows me a brief presentation of something, and did you see it? And I say, no. Okay, now my report is a combination of two things, whether I did actually see it and my decision process. Okay, So maybe I did see it, but my decision process, I thought, in effect, if I were to put my decision process in words, it may have been like, maybe I saw it, but I'm really not sure enough to say I saw it. Okay, so there's a decision process, and signal detection theory tries to model perceptual report in terms of these, both the perception and the decision. And it's a tricky thing, and there's a lot of disagreements about signal detection theory. So this is a sort of long-winded way of saying that there will always be controversies. But I think that if you use the technique of starting with believing the subjects when they're really, 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 really sure, then and in fact, there is a form of blindsight for normal people done by this guy Kentridge. Took him years to do, but he's able to make something invisible and still have an attentional cue in it that attracts your attention. It's very cool stuff. Actually, this is an experiment I could show you that I have on my hard drive, but it would take too long to explain.
Thank you. I have one question myself, but I would like to ask you something that some of the people are wondering, because there are people seeing things on YouTube, and some of them have contacted me per Facebook. So I have one question from one colleague of us, Vasilis Sompanidis, and I want to ask this question to you. I'm just reading. So you have a nice analysis with 7 points for what it is to see an object, but what is exactly to attend an object? Why insist, for example, that you need to be able to count the number of X? One might assume that to attend to X you just need to be responsive to changes to it or some such. So what exactly is to attend to X? And is there agreement on your definition?
Is there a what?
Sorry. Agreement in your definition.
Yeah. Okay, so what I said when I introduced this is I'm talking about object-based attention. And I mentioned the main property of object-based attention, as it is used, remember I mentioned that John Duncan discovered this thing, is that when you're cued to one part of an object, you find it easier to identify something in another part of that object. It's it's a robust phenomenon. It's not a huge phenomenon. That is, the differences are relatively small, but they're very robust, and there are many different aspects of it. It depends on how good an object the object is, and there are various measures of how good an object is from the point of view of vision. The better it is, the stronger the effects. It affects perceptual learning. It affects efficiency of search. So it affects many different aspects of vision. So I think that's a pretty widely agreed idea of what object-based attention is.
Thank you. And now my question. So it was you have already asked me. That was not my question.
Okay.
Oh.
Well, in your talks, you suggested that you can have conscious perception without attention and without cognition. And I understood what conscious perception is not, but what is it? Are we supposed to take conscious perception as a primitive? Are we supposed to say we cannot understand conscious perception as a sum of diverse building blocks? And in addition, do you think that there are more notions in addition of attention and cognition that in the future can be shown to be not constitutive of consciousness, but that in the present we think are part of it? Thanks.
Yeah. Okay. This is a question more or less the same as a question I often get, and I always have trouble answering it. Okay, so let me say two things. First of all, I think the best we can do by way of saying what conscious perception is or consciousness is by way of trying to indicate to people what it is. If they don't have it themselves, they'll never be able to tell. And sometimes I quote Louis Armstrong, who when asked what jazz is, said, if you got to ask, you ain't never going to get to know. It's a somewhat, impolite way of answering the question. But anyway, it's not exactly what I think anyway, because what I think is that it's important to do conceptual work on the notion. So, we all know that the word conscious is a multiply ambiguous word. So I think the major senses of consciousness are phenomenal consciousness, what I call access consciousness, but then there's also a kind of monitoring consciousness where people can report on various aspects of their conscious state. Self-consciousness, so where some kind of consciousness of the self, which may be missing in certain kinds of what are called flow experiences. I don't know if you know about flow. This is a word that's often used in the U.S. for, when you're in the midst of some activity that is occupying all your attention. People sometimes say that they lose the sense of themselves. Okay, so that's, there's these flow experiences. So that shows that self-consciousness is a different kind of thing from phenomenal consciousness. So I think we need to make a whole lot of distinctions. I don't think that we can just say, consciousness, we all know what it is, because, we're putting a lot of things together that need to be separated. But when it comes down to what phenomenal consciousness is, all I can do is say things like, it's like, it's an example of when something smells a certain way or looks a certain way or feels a certain way. But if you then say, what's that? Then I come to the end. John Searle famously said the following: consciousness is what starts when you wake up in the morning, continues throughout the day until you fall into a dreamless sleep, ... or otherwise become unconscious.
Thanks.
Ned, what's your present view on whether qualia is constitutive of phenomenal consciousness or not?
Okay, so the term quale, or qualia in the plural, is a locus of disagreement. It's used differently by different people, and even I myself have used it differently. Dan Dennett, in a famous article called Quining Qualia, claims there are no such things, but he defines qualia as properties of the mind that are non-physical, ineffable, I don't know. The non-physical part really sticks for me. So I think maybe they are physical, because maybe they are identical to, or at least grounded in physical states. Maybe, it all depends on what you mean by qualia.
What you just said before, smells and so
on. Yeah.
Okay. The answer is yes.
Yes.
Okay, thank you.
And there it goes.
I have one question regarding relations of grounding between seeing different things. So in attention, people distinguish, as you mentioned, attention to a location, attention to an object, attention to features, and it's a nice question about how are they related. Now, in the case of seeing, you seem to accept Barth's ideas as a departing point. So basic vision, so conscious vision, is object directed. What we see are objects, so that F, we attribute properties to objects. And with this view in mind, I would like to ask you something about some a priori arguments given by Shoemaker in the 68. So when we attribute a property to an object, this requires an identification. And as a matter of fact, you took identification as being a paradigmatic case of attribution to properties to an object. Now, he claimed that not all representation can be based on this identification, because in order to attribute a property to an object, we need to already identify the object. Now, in the case of Barthes, if I remember correctly, if not, please correct me, I think that he takes visual representations as being something irreducible, but many people would disagree. So if we take perception of an object as the most fundamental one, we would be in trouble. So I would like to ask you whether you have any views on that.
Yeah, I do. Okay, so I'm going to appeal to Burge. So he basically, so this is a topic that is crucial to his view of perception, and I think he's right about this, which is that, remember, he distinguishes between the form of a percept and the form of a basic perceptual judgment, that F versus that is F. Okay, part of that idea is that the role of the F in perception, the role of that F is to help you get to the that. That is, its role is to make the percept be about the thing, to distinguish to help to distinguish what the percept is. It doesn't do it all by itself because the causal features are also important. But its role is exhausted by getting you to the referent in the case of successful perception. In perceptual judgment, by comparison, it is, as Shoemaker says, that you need, if you have that is F, the F has an attributive use in the sense of it can be an attribution to something that's identified in some other way. So he makes that distinction between the role of an F being to determine the referent rather than to have an independent attributive function. I forget that he has terms for this, and I don't remember what his terms are, but that's the basic idea. The basic idea is that in perception, the attributive does not play a predicative, I guess he uses the word predicate maybe, a predicative role, whereas in judgment it does. And so that's perfectly compatible with Shoemaker's idea that you need to be able to identify the thing independently of the predication.
Thank you very much. Just to clarify.
I think we need to finish. Here is the thing, as you say, here is the thing. You repeat that. We need to finish. It has been a great experience to have NetBlog for 6 sessions, and now I think that there could be consciousness without concepts, something that for accountant is really difficult. So thank you very much. There are people that want to have a picture with NetBlog. Perhaps we can make a group picture if you want to come to the front, and then we do it. So thank you very much, NetBlog.
But I want to thank everybody. I want to thank everybody for asking such great questions that have really pushed me to the limit in being able to answer them.